Let's start by defining equivalent fractions. Equivalent fractions are equal fractions with different denominators. Look at the two circles. The first circle is divided into two parts. One of those two parts is shaded in. The second circle is divided into four parts. Two of those four sections are shaded in. But clearly both circles have 1/2 of the circle shaded in. So 1/2 is the same as 2/4. What if we wanted to know if our circle was divided into 8 sections? How many would we have to shade in to still be equal to 1/2? You could draw a new circle, divide it into 8 sections, color half of it, and then count up how many sections were shaded. But mathematically, we can start by looking at the denominators and think, what do you multiply 2 by to get 8? That would be 4. Then to get the new numerator, also multiply the top by 4. So on the top would be 4. 4/8 is the same thing as 1/2. 7 over 11 is equal to what over 33? So think, what do you multiply 11 by to get 33? That would be 3. So also multiply the top by 3, and the new numerator is 21, and those are your equivalent fractions. Whole numbers don't appear to have a denominator, but all whole numbers can be written over 1. Remember that the fraction bar means divide, so 5 divided by 1 is still just 5. Now look at the denominators. What do you multiply 1 by to get 6? That would be 6. Also multiply the top by 6, and the numerator is now 30. Sometimes we want to go backwards. We want to go from a larger fraction to a smaller. 28 over 32 is equal to what over 8? So you have to think, how do I go from a 32 to an 8? You divide by 4. So then also divide the top by 4, and the missing numerator is 7. We use this process to reduce fractions, to get them in their lowest terms, or to get them in their simplest form. Some textbooks will ask you to write a fraction in simplest form. Others tell you to reduce the fraction. These mean the same way. Either way, we're saying that the numerator and the denominator can only be divided by 1 in common. Sometimes it's easy to reduce a fraction in your head. If I look at 2 over 14, and I want to think, what do 2 and 14 both divide by? Hopefully, quickly, you could come up with 2. So if I divide both the top and the bottom by 2, then I have 1 over 7. And so that is my reduced fraction, or my fraction in simplest form. Other times, it might not be as easy to just look at the numbers and think of what they both divide by in common. So if that happens, for example, 50 over 75, you can break the numbers down into their factors. 50 is the same thing as 5 times 10. 75 is the same thing as 3 times 25. Then I can go farther. 10 is 2 times 5. And 25 is 5 times 5. Now look at the top and bottom. Anything that the top and bottom have in common, you can mark out. So I can mark out these 5s, and then here's another set of 5s. And what you have left is the reduced fraction, or the fraction in simplest terms. So that would be 2 over 3. 50 over 75 both divide by 25. And if you saw that immediately, you could save yourself some time. But again, if that's not apparent to you right away, you can always break the numbers down into their factors. Let's look at one more. 40 over 36. 40 is 4 times 10. It's also 5 times 8. We could have started that way, it doesn't matter. 36 is 4 times 9. Now if you see right away you have two numbers, top and bottom, that are the same, you can go ahead and mark those out. I can go farther with the 10 and the 9. 10 is 2 times 5, 9 is 3 times 3, but I won't have anything to mark out. There won't be anything the same on the top and bottom. So my final answer is 10 over 9. But it's improper. So let's change that to a mixed number. It's 10 divided by 9. So set up a little long division problem. 9 divides into 10 one time. 1 times 9 is 9, and subtract. So my mixed number is 1, and then remainder divided by 9. 1 and 1/9.